All right, in this video, we are going to go over the quadratic formula. And I want to make sure you remember what the formula is and then the different types of answers we can get from it, and then also how to plug it in your calculator. So the quadratic formula is, it starts with a quadratic that's in standard form. So you're going to start with a quadratic that has been set equal to 0. So, and it has to be in the correct order. So you have your x squared term first, then your x term, and then your constant term that doesn't have a variable on it. And it's ax squared plus bx plus c. So when we talk about a, b, and c in the quadratic formula, we're talking about the numbers that show up in front of the x, the coefficients of x, and then the constant. So when you have a quadratic written like that, to solve for x, you would say negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. And we have a special piece of that, that's this part right here. That part right there is called the discriminant. So this part right here is called the discriminant. And the discriminant will tell you what types of answers you're going to have. All right, so we're going to say the discriminant. So if, I'm going to say, I'm not going to write the word discriminant again. I'm just going to say b squared minus 4ac. So if squared minus 4ac is equal to 0 exactly, then you're going to take the square root of 0 here, which is just 0. And so this part will not have any sort of influence on your answer, and you will only have one answer for x, and it will be negative b over 2a. So if your discriminant equals 0, the plus minus square root part doesn't give you anything for the answer. And so then we would say that you're going to have one real root. And root is just another word for x-intercept, which is another word for a 0 of the graph. So we call them roots because we're taking square roots to get the answer. If b squared minus 4ac is less than 0, that means if you get a negative underneath your square root sign, then you're still going to have the plus version and the minus version. You're still going to have 2. But you're going to be taking the square root of a negative number. And when we take the square root of a negative number, we get imaginary numbers. So we're going to say you're going to get 2, and we don't call them imaginary because they have one piece that's real and then one piece that's imaginary. We call that complex. So that'll be 2 complex roots. And then if you have b squared minus 4ac is greater than 0, then again, you're going to have the plus and the minus. You're going to have 2, but the roots are going to be real. Sorry, my light turned up. 2 real roots. Now, when you get 2 real roots, there can be 2 different situations that will happen. So one situation is that this is a perfect square. And the other situation is it's just, I call it a regular number. So a perfect square would be like 1, 9, 25, 144, 100, something like that. A regular number would be like 30. Or 52, or just something you can't take the square root of without getting a decimal. So if you have a perfect square number, then you're going to get a rational root. So a perfect square is going to give you a rational root, so you're going to end up having an x-intercept that is either a whole number or a fraction. If you have a regular number that you're square rooting, you're going to get an irrational root. And irrational roots are like funky decimals, just like weird decimal answers. You have to round to write them down. They cannot be expressed as a fraction. So if you do the quadratic formula and you get a rational root answer, that means that that original problem could have been factored. You use the quadratic formula on it, but if you hadn't used the quadratic formula, you could have solved it by factoring. Any problem where you have an irrational root or you end up getting two complex roots, that means that you had to use the quadratic formula. You had no other option. You couldn't have done anything else. So for this assignment, we're really going to focus in on which problems you have to use the quadratic formula on, because we've already reviewed solving by factoring. So now we're going to review solving using the quadratic formula because we have to. Right? So we're going to do a couple examples just to make sure that this makes sense. So example 1 is 3k squared plus 2k equals -3. And so the first thing I'm going to do is make sure that this equals 0, and it doesn't right now, so I have to add the 3 to the other side. So 3k squared plus 2k plus 3 equals 0. So this means that my A term is 3, my B term is 2, and my C term is also 3. So A, B, C. The reason that I'm circling the sign in front is because I want to make sure that it's positive, or if it's negative, I want to make sure I keep that in mind. So I'm not just looking at the number, I'm making sure that I know what the sign is. So we're going to say K equals -b plus or minus the square root of b squared minus 4 times A times C divided by 2A. All right, and because I know that some of these answers are going to be imaginary, I'm not going to plug the whole thing in all at once. I'm just going to find the discriminant to start. So 2 squared minus 4 times 3 times 3. And my discriminant is -32. So I'm going to go ahead and write this. Now, since my discriminant is a negative number, that means that I'm going to have imaginary roots, because if I try to type the square root of -32, my calculator is going to give me an error. It's a non-real answer, which means it's imaginary. So what I do whenever I see that is I take this, I make it positive, and I put an I right in the front of the square root sign to say to the person looking at my paper, yes, I have an answer mathematically, but it's an imaginary answer. So then my conclusion here is that I have -2 plus or minus I square root 32 over 6, and that gives me the two solutions that I expected for the quadratic formula. One solution is the plus, one solution is the minus. So I have two versions. All right, the next example, we're going to do 4m squared plus 5 equals 4m. So again, the first thing I need to do is make this equal 0. So I'm going to go ahead and minus the 4m over to the other side. So I have 4m squared minus 4m plus 5. And again, I'm being really careful to write these in the correct order, because if I don't, then I'm going to choose the wrong number for my A and my B and my C, and then I'm going to get the wrong answer. So here's my A value. My B value is a 4, but it's a -4. And then my C value is 5. So I'm going to go ahead and get started. I have M equals, it's -b, so I'm going to say negative of B. And if you have a negative of a negative, then those kind of cancel each other out and it makes a positive. So if I have -b, that's actually going to become a positive 4. Plus or minus the square root of, and I have to do I have to do b squared, which in this case is -4 squared. And so I have to put this in parentheses. If I do not put it in parentheses, I will get the wrong answer. So let me show you why. If I do -4 squared, my calculator is going to square the 4, but it's not going to square the negative. If I do negative 4 in parentheses squared, it's going to give me 16 like it should. So if you think about it, negative 4 squared is supposed to mean negative 4 times negative 4. And that answer should be 16, which is why when we do it, we have to put the parentheses there. So I have b squared minus 4 times a times c, all divided by 2a. And so again, the first thing I'm going to go ahead and do is type in the discriminant to see what number I get for that. And this time I get negative 64. So again, we have an imaginary number as the answer. So I'm going to go ahead and make this a positive and put an I in the front. And so that means that I have m equals 4 plus or minus, and this one is interesting because 64 is a perfect square, so I can go ahead and square root that. The square root of 64 is 8, so I can say 4 plus or minus 8i. And then if you look at all these numbers, they're all even. And they all have 4 in them. They're all multiples of 4. So what I can do now is I can go through and divide each of them by the same thing. So I'm going to say divide 4 by 4 and I get 1. Divide by 4 I get 2. Divide by 4 I get 2. And so my solution here is 1 plus or minus 2i divided by 2. All right, 2 more examples. All right, so for this problem, you actually could solve by taking square roots, which is a valid method, but this video is all about practicing the quadratic formula, so we're going to go ahead and make it equal 0 and use the quadratic formula for it. So I'm going to go ahead and minus the 17 over. And if you notice, this is a binomial, not a trinomial. And we have the k squared term and we have the constant, but we don't have the k term. So I'm going to go ahead and rewrite this with a 0. So I'm going to say plus 0k minus 17 so that I know exactly what to do for my quadratic formula. So my a is 11, my b is 0, my c is negative 17. So I have negative b plus or minus b squared minus 4 times a times c divided by 2a. Negative 0 and 0 are the same thing, so I'm going to go ahead and just say 0. So I've got 0 squared minus 4 times a times c. So you'll notice that even though I have a 0 in there, I'm typing it in exactly the same as I've typed in all the other discriminants. I get 748. Okay, so now that I have this, I know that 748 is not a perfect square, but if you don't know that, you can check it. It's a decimal, so it's not a perfect square. So at this point, I'm going to go ahead and plug this into my calculator. So to be able to type it in the way that it looks on my paper, I need to get a fraction on my screen. And the way that I do that is I hit the alpha button and then the y equals button. So alpha, y equals, n over d means numerator over denominator. So I have 0 plus the square root of 748 divided by 22. So the first answer is 1.243. We're going to go ahead and always put 3 decimal places. So I'm going to say k is approximately 1.243. You can do a squiggly equal sign if you want, but you don't have to. And then I have to type it in again with a minus. So I'm going to go up arrow and highlight this and kind of grab it. So if you're highlighted on it, you can press enter and it will pull it back down for you. And then I'm going to go and put a minus in there. so negative of the same decimal. The only reason we got the same decimal twice, but with a positive and a negative, is because the b value was 0. Normally, you're going to have two completely different decimals here. Okay, we're going to do one last example, and then I think you guys will be good. 3m squared plus 4 equals negative 10m. So again, first thing, we make it equal 0. And we have our A and our B and our C. And so I have m equals negative b plus or minus b squared I made a little mistake here. Hold on, I'm going to pause. Don't worry, we're cool. My example problem had a positive there and I didn't notice it. So I just want to make sure this problem is still going to work out. B squared minus 4 times A times C divided by 2A. All right, so I'm going to go ahead and find my discriminant. I can go ahead and write the rest though. 10 squared minus 4 times 3 times 4. I get 52. And that's not a perfect square. So I'm going to go ahead and plug this in and see what my decimal answers are. So I hit alpha y equals, and I have negative 10 plus the square root of 52 divided by 6. So I'm writing 3 decimal places. The 4 is followed by an 8, so I rounded up. And then I'll go ahead and go up and grab this and change it to a minus. Negative 2.86. The 8's followed by a 5, so 9. And there's my two irrational answers because they're decimals that have to be rounded to be written down.